Hello, everybody. So we're going to talk now about the measures of location of data. So we've seen histograms, and one thing that we like about histograms is that they, at a glance, we can look at a picture and kind of get a sense of where the data lives. And we can do that with numbers as well. And as we'll also see, sometimes these numbers about the location of data helps us understand what we should think, how we should think about a number. So what we're going to start with, what we'll mostly focus on in this video, are things called percentiles and quartiles. So I'm gonna just give a definition for a percentile, and then we'll do some examples to try to get a little better understanding of what it is. And then we'll see that quartiles, when we get to them in a moment, are just a particular case. They're special percentiles. So let's just talk about percentiles. So we would say a piece of data is the kth percentile if about k% of the data is at or below that value. Okay, so for instance, if I said something like this piece of data is the 55th percentile, that means 55% of the data is at or below that value. Okay, so there's a couple things before we get into some examples. This word about doesn't really sound very mathy. We like to be specific in mathematics. However, percentiles, there are different ways to compute which piece of data is a percentile, is which particular percentile, and there's different methods that don't always agree. The reason is depending on how much data you have, or one of the reasons is depending on how much data you have, it's difficult to say what a particular percentile is. For instance, let's say I had a data set that was only 3 numbers, like 3, 7, and 10, and I wanted the 25th percentile, right? In other words, I wanted which one of these data points has 25% of the data at or below it, right? Well, it's kind of hard to say which of these data values is that, because I can't really divide up these 3 values into 25%, into groups of 25%. So different methods end up choosing different ones of these, and the differences don't really matter. They only really come out when there's really small data sets. For most of the data we look at that's larger data sets, it won't really be a big deal. And for the most part, we're not going to do it by hand, and we'll use things like Google Sheets to do it for us. And if there's any disagreement between one program and another, the difference is going to be extremely minor and not of concern. We use this to get a sense of the data, and if we're off by a 1/10 or something like that from somebody else's assessment, it's not going to change our discussion. So let's give some examples of this. So one thing that's useful about percentiles is helping us understand the meaning of a piece of data. So for instance, right, I don't have children, and if you don't have children and you've been around people who do have children, especially when they first have children, one of the things you hear about constantly is the weight of the child, right? Apparently getting children to consume food and put on weight is a challenge for lots and lots of parents. And if you don't understand how much an infant is supposed to weigh, the weights are meaningless. So for instance, if somebody told you that their newborn was, let's say, 5 pounds, 8 ounces, right? I don't know if that's a heavy baby, a light baby, a medium baby. I don't know anything. I don't have any context to understand what they're telling me, right? And even for most parents, they probably don't understand. So often what they'll hear is a percentile. I don't have this one exactly. I looked it up, and this is about the 8th percentile. In other words, only 8% of babies are this weight or smaller, right? So now that tells me something very specific, that this is a rather low birth weight, right? If only 8% are at this weight or smaller, that means more than 90% are heavier than this. And so that tells you how to think about this weight, even if you don't know anything about how much babies typically weigh, right? So it can put the data in context for you. If you've ever taken any kind of standardized testing, like an SAT type thing, you don't necessarily know what the scores mean, right? I know they've redone the scoring system since I took it, so when I hear somebody's score, I don't even know out of how many they're talking about. So if somebody says, I scored 700 on this test, I don't know if 700 is good or bad, but if somebody tells me they scored in the 85th percentile, then I know they did rather well, right? Their score is at or above 85% of everyone who took it. So that tells me how to think about that data, okay? So that's what percentiles are. There is a formula for computing percentiles in the book, which you should use on homework. But I'm going to talk mostly about quartiles in this video. So and this video, I'm mostly going to focus on how to find them, and we'll do other videos with some other ideas about what the meaning of these things are. But quartiles, the quartiles are just special percentiles. There are 3 of them, Q1, Q2, and Q3. Q1 is just the 25th percentile. Q2 is the 50th percentile. And Q3 is the 75th percentile. Okay? So let's talk about how to find these 3 percentiles. And there's really only 2 ways I'm going to expect you to know how to do, especially for an exam or something like that. A, we're using software. So if we have data in Google Sheets or Excel, those will find percentiles for us, and that's perfectly reasonable to do. If we have a small data set, then we can find these on our own, and that's the process I'm going to go through right now. So let's take a look at 3 data sets and find these 3 values for them, right? The 25th percentile, the 50th percentile, and the 75th percentile, right? This is the number, this is the piece of data that's above, at or above 25% of the data. This one's at or above 50%. This one's at or above 75% of the data. So let's take a look. So here's the method we can use for small data sets. These are 3 separate data sets. Let's find these numbers for all of them. The first one I have here, this first data set has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data, okay? So what we're going to do is we're going to find the middle number, right? So if there's 11 pieces of data, the 6th piece of data has 5 numbers below and 5 numbers above. This is going to be Q2, the 50th percentile. Now I look at the bottom half. There are 5 pieces of data. The middle piece of data is the number 5. This is going to be Q1. So Q2 split all of the data in half. Q1 split the bottom half in half. And then we do the same thing up above. We get Q3. Right. So this set of data has Q1 equals 5, Q2 equals 6, Q3 equals 9. And what we often give when we give these quartiles is we'll often list the minimum. So in this case, that's 3, and the maximum, just the largest number, is 14. And we get this little summary of the data. right? I'm not giving everybody all the data, but by giving them these 5 numbers, we get a little sense of how the data is, where the data is located. There's about 25% between 3 and 5, about 25% between 5 and 6, about 25% between 6 and 9, and about 25% between 9 and 14, right? I always say about because 11 doesn't split up perfectly into quarters, and so it's not totally precise, the 25%, but it gives you a good sense. Again, it's not really sensible for data that's this small, this few data, but we're doing it to understand what these things tell us. So you can see how this divides it up into 4 groupings. This set of numbers, by the way, is sometimes called the 5-number summary. Okay. Let's do another one because there's sometimes some things that don't work quite as easily as the first one we did. So here's another set of data. So now I'm looking at this set of data and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up here I had 11 pieces of data. I could split it right in half by choosing 6. Then there's 5 above and 5 below. I can't do that now because there's 10 pieces of data. However, if I split between these 2 numbers, then there's 5 data above and 5 data below. Okay, and we'll call this Q2. Well, what number should it be? It should be the number right in between 51 and 59. In other words, 51 plus 59 divided by 2, or 55, right? So I'm not choosing an actual data value. Q2 is going to be the number in between these 2. Okay, it splits the data in half. So half the data is above it, half the data is below it. Okay. Now I want to find Q1 and Q3. So I look below Q2, there's these 5 numbers. So I can choose this to be Q1 and this to be Q3. So here's Q1, Q3. So now my 5-number summary for this data looks like it's got a minimum of 41. Q1 is 43. Q2 is 55. Q3 is 60. And the maximum is 67. There's my 5-number summary for that data. Okay. So one way we sometimes think about it is we're just doing the same process over and over again. We're splitting the data in half, and then we take the bottom half and split it in half, and the top half and split it in half. The only trickiness is if we have an odd number, it's very easy. There's a number right in the middle, and then if there's an odd number again, there's a number right in the middle. When there's an even number, we have to take the average of 2 numbers, right? We add the 2 numbers together that are in the middle and divide by 2. Let's do one more example. I've got a 3rd data set that has 8 pieces of data. So again, there's no number right in the middle, but I can split this data in half with 4 below and 4 above. And so Q2 is going to be the number in between these 2 numbers. So I add them together and divide by 2. I did this ahead of time and I got 35, 30.5. So now I look at the bottom half and notice again, I have an even number, so I have to do the same thing. There's 4 pieces of data, so there's no number in the middle, but I can split between the 2nd and 3rd pieces of data. And so I would add 147 plus 942 and divide by 2. And this gives me 544.5. And then I do the same thing up here for Q3. I add together 5,935 plus 6,000, divide by 2, and I get 5,967.5. So the 5-number summary for this set of data is going to be the minimum, it's 112, Q1 is 544.5, Q2 is 3,530.5. Q3 is 5,967.5. And the maximum is 6,001. Okay. So in all these cases, we end up with this nice 5-number summary, right? Again, it's a little silly. When I've only got 8 pieces of data, to summarize them with 5 pieces of data hasn't really changed much, right? But what we use this for, what we really use this for, is if I have 80 pieces of data or 8,000 pieces of data, having the percentiles, right, tells me something. It lets me summarize the data quickly. For instance, going back to the birth weight, knowing that about 8% of babies are below 5.8 ounces tells me a lot more than I would get from staring at a list of birth weights, right? You'd see birth weights all over the place, and it'd be very difficult to understand, to glance at the thousands and thousands and thousands and thousands of birth weights in the country each year and understand what your birth weight means, right? Or your baby's birth weight means. But by giving percentiles, you can understand that pretty quickly. One last thing I'll mention, there's a special name we give to Q2 that we'll talk more about later, but Q2 is sometimes called the median, okay? So we might refer to it as the median, the middle number, right? Notice that we call it the middle number, but it doesn't necessarily have to be, or the middle data value, it doesn't necessarily have to be one of the data values. It can sometimes be the average or the mean of 2 data values if there's no middle data value. All right, that is going to be it for this one. For my purposes, if I ever give you a quiz or an exam and ask you to find the quartiles or the 5-number summary for a set of data, if I'm not asking you to use software to do it, I'm asking you to do what I did here. Just picking the middle numbers and picking the middle numbers again, just so that we understand what these numbers mean, right? If you have 5,000 pieces of data, you're not going to want to organize it by hand this way. Okay, that's it for now. Thanks, everybody, and I will see you next time.